To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the second chapter of this lesson. Do you remember what we learned in the first chapter? In the first chapter, we learned about the production of sound. Under that, we learned that the sound is produced by vibrations of objects. Now, under this chapter, we are going to learn about the propagation of sound. Do you remember at the beginning of this lesson, I told you all, we are going to learn the lesson under two main topics. That is the production of sound and the propagation of sound. So, this is the second main topic of the lesson. What is the meaning of propagation, children? So, before we start this chapter, the propagation means moving or transmission of sound. So, under this chapter, we are going to learn about the traveling of sound from one place to another place. So, we are going to learn about sound traveling through different media, solids, liquids, and gases. Okay? Right. Look at this one, these astronauts. In the classroom, you hear the voice of your teacher. You can hear different voices, not only your teacher's voice. If your friend talks to you, you can nicely hear that voice as well, right? But in space, two astronauts cannot hear each other's voices despite being closer to each other, right? So even though in the space, even though astronauts are close to each other, you cannot hear the sound. Okay, they cannot hear each other's voices. What is the reason, children? So under this lesson, we are going to find out the reason for this too. So for this one, we are going to do a very interesting activity next. So the activity is testing whether a medium is needed for the propagation of sound. Okay, what is the meaning of a medium? Whether any kind of particles present, right? So last year we learned that the things around us can be divided into two things. What are they? Matter and non-matter or energy. So matter means the things with the mass and that occupy space. So when you consider matter, there are three states of matter: solids, liquids, and gases, right? So solids made up of solid particles, liquids made up of liquid particles, and gases made up of gaseous particles, okay? So testing whether a medium, so when in a certain medium, if a certain place contains of solid particles, that type of medium is known as a solid medium. If gaseous particles present, that type of medium is known as gaseous medium. If liquid particles present, that type of medium is known as a liquid medium. So here we are going to learn whether a medium is necessary for the propagation or the traveling of sound, okay? So for this experiment, we need these instruments. We need this glass instrument called the bell jar. Look at the shape of it. It looks like a bell. That is why this is known as a bell jar, right? And we need a small vacuum pump, right? I will explain why. And we need an electric bell, dry cells, and a switch, okay? Let's write. We need a bell jar, a vacuum pump, an electric bell, dry cells, and a switch. Right, children? A bell jar, a vacuum pump, an electric bell, dry cells, and a switch. So what are we going to do with these materials? Let's see. You have to set the apparatus like this. Now this is the bell jar. You all can see this electric bell is fixed inside the bell jar. And one part of the vacuum pump is fixed to the other side of the bell jar. Right, children? Okay, so what you have to do is fix the electric bell in the bell jar as shown in the figure. Right? Connect it to dry cells and to a switch to supply electricity. Right? From here, you have to supply electricity by connecting it into dry cells. Okay? Now then, connect a vacuum pump to the bell jar so that the jar can be evacuated. So why do we need a vacuum pump? We need to remove air inside the bell jar. Right, children? We need to remove the air inside the bell jar. That is why we need a vacuum pump. Okay? First, switch on the electric bell and record your observations. Now, in the first instance, you are not going to turn on the vacuum pump. You are going to just leave it. Right, children? So, before you turn on the vacuum pump, first of all, you need to turn on the switch and you need to supply electricity to the electric bell. And you should check whether you can hear the sound of the bell. Okay? Then switch on the electric bell again while evacuating the air in the bell jar using the vacuum pump. Record your observations. Now what you have to do is, while the bell is still ringing, you have to turn on the vacuum pump. So as I told you all, when you turn on the vacuum pump, all the air particles inside the bell jar will be sent out. Right? Now even though we can't see, bell jar is filled with air, then what happens? All the air particles will be sent out. Okay? So you have to check what happens then. Right? Finally, switch on the electric bell again when the bell jar is completely evacuated. Right? Even without switching it off, you can still do the activity. While the bell is still ringing, you can do the activity. Right? Or you can simply turn it off, remove all the air present in the bell jar, and then turn on the, you can supply electricity again and check whether the bell is ringing or not. Okay? Then finally switch on the electric bell again when the bell jar is completely evacuated. Right? Which means there are no air particles in it. Record your observations. So I'm going to add a little bit at the end of this experiment. After doing or following all these steps, what I'm going to do is, after this last step, I'm going to send air again into the bell jar. We need to send the air again into the bell jar and check what happens to the ringing of the bell. We'll do this activity now. Right, children? By doing this activity, we are going to prove that sound needs a medium to travel or to propagate. Now, I already explained you all what we need to do this activity. Can you all see this is the bell jar that I explained you all about? And you all can see there's a bell that is connected to the bell jar. And from these two wires, you all can see from inside, these two wires are coming, and from here, it is connected to the electrical supply, right? And this tube is connected to a vacuum pump. Why are we going to use a vacuum pump, children? Using the vacuum pump, we can remove the air present inside this bell jar. Now, even though we cannot see, this bell jar is filled with air, right? And at the same time, you have to pay attention to this small rigiform ball that is fixed to this bell. Okay, you all can see the pink color rigiform ball fixed to this bell. Now, first of all, I am going to supply electricity to this bell and we are going to observe. Right, children? Can you all see the bell is ringing? You can hear the bell is ringing. At the same time, look at this rigiform ball, children. It is vibrating because it touches the surface of the bell, and so you all observe that, children. When I supplied electricity, the bell started to ring, and you all observed that this tiny rigiform ball fixed to this bell, what happened, children? It started to vibrate. Why does this happen, children? When the bell rings, that bell cover vibrates accordingly. As this small rigiform ball touches the bell cover, that also vibrates. Okay? Watch that again, children. Pay attention to that. Right. So that was very clear. Okay. So when we supply electricity, the bell is ringing. At the same time, the small rigiform ball also starts to vibrate. It moves. Okay. Now what I'm going to do is I'm going to supply electricity again. At the same time, I'm going to switch on the vacuum pump. Observe very carefully what happens, children. Okay. Right, children, what can you observe? You can hear the sound is decreasing. Sound is decreasing, and at the same time, the rigiform ball is moving in the same way. Right. Now what can you see, children? Can you hear anything? You can't hear anything. But look at the rigiform ball. Rigiform ball is still moving, which means even though we can't hear the sound, what happens, children? The bell is still ringing. Okay, rigiform ball is moving means the bell is ringing, because only when we supply electricity, only when the bell started to ring, the rigiform ball started to move. Okay, here the rigiform ball is moving means the bell is still ringing. Okay, children. So therefore, you know that even though you cannot hear, the bell is still ringing. Right, children. So you all observed what happened very clearly. What happened, children? Earlier when I supplied electricity, the bell started to ring, and according to the ringing of the bell, this small rigiform ball also started to move. Right? Because of the vibration of the bell, this happens. Okay, children? Then what happened? When I switch on the vacuum pump, you could not hear, after a little while, you could not hear the sound of the bell. The sound of the bell gradually decreased, and at one point you could not hear anything. Okay, but at the same time you all clearly observe that the small rigiform ball is still moving, which means even if we could not hear, that time the bell was ringing. Only according to the ringing of the bell, this rigiform ball is moving. Now you all can see at the moment the bell is not ringing. This rigiform ball is also not moving. Okay, children, because I have disconnected the electricity supply now, right? Which means even though we could not hear at that time, the bell was still ringing. Why does this happen, children? When we connect this tube to the vacuum pump, what happens? The air particles inside this bell jar is removed by this vacuum pump little by little. Okay, children? There what happens? The air inside the bell jar gradually decreases. Accordingly, the sound inside the bell jar, the sound we heard also gradually decreased. Okay? When there are no air particles inside this bell jar, at that point, even though the bell is ringing, we cannot hear anything. Okay, children? Which means the sound travels through the air particles and through to our ears. Okay? Inside the bell jar, if there are no air particles, is there any medium for the sound to travel? No, there is no medium for the sound to travel. Okay, that is why we could not hear. Even outside the bell jar, there are air particles to bring this sound to our ears. But from the bell to the bell jar, to the outer walls, there is no medium. Right, children? Therefore, even though the bell is ringing, we cannot hear its ringing because there is no medium for the sound to travel. So after doing this activity, it's very clear that the sound needs a medium to travel. Right, children? So that activity was very interesting. I hope you all enjoyed the activity. So what did we do? First of all, before we turned on the vacuum pump, we supplied electricity to the bell jar. What did you hear? We could hear the ringing of the bell very clearly. When we remove the air present in the bell jar, gradually using this vacuum pump, what happened, children? The sound of the bell jar gradually fades and finally it completely stops. Okay, children? But at the same time, we could see this part of the bell moving, which means even though we cannot hear the sound, the bell is still ringing inside. We did not stop the supply of electricity. Right? We did not stop the supply of electricity, But what we did was we removed the air in the jar using the vacuum pump. Okay, so we could hear that when we are removing the air from this bell jar, the sound of the bell gradually fades and finally it stops. Right, children? Then what happened? Even though we could not hear any sound, we could clearly see that the bell was still working or ringing inside. So what happens here? When the air is filled inside the bell jar, we can hear the sound clearly. This happens because we can hear the sound. Now the sound is produced by the bell. This sound comes to our ear through air. So inside the bell jar, when air particles present, from one particle to the other particle, the sound travels, right? So then through this glass cover, it comes to our ear, right? It spreads to the outer air and then finally we hear that it reaches our ear. Right, children? But here what happens when we remove the air particles, even though the sound is produced here, can that sound move from this place to this place? No, because there's no any air particle in order to carry these sound waves, in order for the propagation of sound. That is why when we completely remove the entire amount of air from the bell jar, we cannot hear anything, but we can still see the bell is working. Even though it works, we can't hear anything. That is because there's no air particles inside, right? So what is the conclusion that we can come up with after doing the activity? That sound needs a medium to travel. Sound does not travel through a vacuum. Sound does not propagate through a vacuum, right? Now when we remove all the air present inside the bell jar becomes an empty space. Inside the bell jar becomes an empty space. So this type of empty spaces without any medium we call a vacuum, right? So it's very clear, sound does not travel through a vacuum. If it travels through a vacuum, even though we remove air, we should hear the sound of the bell, but it did not happen. Right, children? We'll write this observation and conclusion. Observation. When the bell jar is filled with air, the sound of the bell can be heard. When the air inside is gradually removed, the sound fades gradually. And finally stops. But we can see the bell is ringing. When air is sent back to the bell jar, the sound of the bell can be heard again. Right, children? When the bell jar is filled with air, the sound of the bell can be heard. When the air inside is gradually removed, the sound fades gradually and finally stops. But we can see the bell is ringing, right? When air is sent back to the bell jar, the sound of the bell can be heard again, right? So what is the conclusion? The sound needs a medium to propagate or to travel. And sound does not propagate through a vacuum. Right? The sound needs a medium to propagate and the sound does not propagate through a vacuum. Okay? Right. So here the same thing is given. It's clear that the ringing of the bell is heard only when there is air in the bell jar. Right? Sound is not heard in a space where there is no air, which means it's a vacuum. So this is why the astronauts cannot hear each other's voices, because there are no air particles in space, which means it is a vacuum, right? So sound is not heard in a space where there is no air, right? Thus it's clear that a medium is essential for sound to propagate. Medium is essential for sound to propagate, okay? We hear the voice of the teacher in the classroom because sound travels through the air towards our ears. So when your teacher talks, you can hear it because through the air, what happens? The sound reaches your ear, okay? But two astronauts in space cannot hear each other because there is no air in the space for sound to travel through, right? Thus, it's clear that sound does not travel in an empty space, which means a vacuum, and sound needs a medium to travel, right? Sound which is produced from a sound source travels from where it is originated is known as the propagation of sound, which means sound traveling from one place to another place from its source. What is the meaning of sources of sound, children? The objects that produce sound. Right, children? So sound which is produced from a sound source travels from where it is originated, where it's produced is known as the propagation of sound. Right? This is the definition of propagation of sound. Right? We hear different sounds when sound propagates through the air to our ears. Right? So if the sound does not propagate, we can't hear anything because sound moves from one place to another place. We can hear different sounds. Okay, children? Let's move on to the next activity. Finding out whether sound propagates through liquids. By now we know that sound propagates or travels through air in a gaseous medium, right? By the bell jar experiment, it was clear when we removed the air, we could not hear sound, but when air is sent back, we could hear the sound again, okay? Here we are going to find out whether sound propagates or travels through liquids. So, for the liquid, we are going to use water here, okay? So, what do we need? We need plastic funnels. We need 3 of these plastic funnels and we need pieces of rubber tubes, balloon membranes, because we need to cover the mouth of these plastic funnels with the balloon membranes, a basin of water and a Y-shaped tubes. These are known as Y tubes. The Y-shaped tube is needed to connect these rubber tubes with each other. Okay? Right. We need 3 plastic funnels. Pieces of rubber tubes balloon membranes, a basin of water, and a Y tube. A Y-shaped tube, right? 3 plastic funnels, pieces of rubber tubes, balloon membranes, a basin of water, and a Y tube, right? What is the method? We have to make the apparatus like this. Now this looks like a stethoscope, right children? Stethoscope used by the doctors, a bit like that, right? Assemble the equipment as shown in the figure. Now look at this. This is the Y tube. I told you all you need the Y tube to connect these rubber tubes with each other. Okay. So these are the funnels. Now they are labeled as A, B and here C. This is C. Right? A, B and C. You all can see each funnel. The mouth of each funnel is covered with the balloon membranes, right? And you all can see they are connected with the rubber tubes. We label that as well. These are the rubber tubes. Rubber tubes. And this is the basin of water. Basin of water. So when you draw a diagram, it's very easy to understand what should be done. Okay? So when you draw a diagram, it should be a labeled diagram too. Right? Okay. So what do we have to do? Assemble the equipment as shown in the figure. Hold funnels A and B on your ears and dip funnel C in the basin of water. Right? You have to keep these A and B funnels on your ears and you have to immerse. So dip this C funnel in water. Right? Make a sound near the funnel in water. Right? You should make a small sound in water near the funnel C. Right? Record your observations. Actually, you have to check whether you can hear this sound through this setup. Right, children? Let's do this activity now. Right, children? Now, we are going to do this activity to show that sound travels through liquids, okay? So, here I have a trough of water and laboratory stand. And here I have the apparatus that I'm going to use to do the activity today, right? Now, I already explained you all how to make this apparatus. Here I explained you all that we need 3 funnels to do that. You all can see we have 3 funnels. The mouth of each funnel is covered with a balloon membrane, right? And these 3 funnels are connected together with these rubber tubes, and each rubber tube is connected with this Y-shaped tube. Look at this one. Right, children? Now, what do we have to do? We have to immerse one of these funnels in water. So, in order to fix this one, immerse this one, I am going to get the help of the laboratory stand. So, at home when you do this one, you don't have laboratory stand, you can get the help of another person, okay? Right. Okay. Now, I am going to keep these other 2 funnels in my ear like this. Okay. Now, I am going to make a sound. You all know that without these 2 funnels, first of all, I am going to do the activity. I am going to make sound in water using this glass rod. Check whether you can hear. Right. You all can hear the sound of water. Right, children? Now I'm going to do the same activity while holding these 2 funnels in my ears. Now I have only one free hand, therefore this time I'm going to use only one funnel. But at home when you do this one, or even at school when you do this activity, you can get the help of another person. You can ask some other person to make sound in water. Okay, right. Right, children. I can hear the sound of water to these funnels too. Right, children? So if I keep my ears, I could hear better. Right, children? So what is the reason, children? Now through air, anyway, we know that we can hear when someone is talking to another person, we can hear the sound through air. Even here earlier, when I was doing the same activity without using the funnels, I could hear the sound of water through air. Right? But when I keep these two funnels, what happens, children? This time air is blocked, but still I could hear the sound through the funnels. What is the reason? You all can see here I made the sound over here. Across this liquid, across the water, the sound travels to this funnel, and from that funnel through the tubes, sound travels to my ears. Right, children? So the sound made in this side of the water goes through the water, reaches this funnel. Through this funnel, what happens, children? I can hear it using the other two funnels. Right, children? I can hear the sound better. Right, children? So it's very clear that sound travels through liquids after doing this activity. Right, children? So you observe this one, but the thing is you cannot hear the sound. But when I was doing this activity, I could hear the sound well. That is why these type of activities you all have to try to do at home. Now, even this setup is not that hard to make at home, right? Try to do this activity at home so you can understand this lesson very well. This part is very important, okay? So what was the observation? What we did was we made the setup like this and we held A and B funnels on our ears, and then what happened? We immersed this funnel C in water and we made a small sound in water, right? So I could actually observe that I could hear the sound made here very, very clearly through these A and B funnels, right? So what is the conclusion? I could hear this one because when we made the sound in water, through liquids, it spreads to C, and through that C, it spreads through the whole setup to our ears. So the vibrations spread through water, through liquids. Right, children? So it's very clear that sound propagates through liquids. Right? Okay. Observation. The sound made in water can be clearly heard. Clearly heard through funnels A and B. The sound made in water can be clearly heard through funnels A and B. Right? What is the conclusion? The sound propagates through liquids. The sound propagates through liquid media. Liquid media. Right? The sound propagates through liquids or liquid media. Okay? Right. Here the same thing. Sound made in water can be heard well through funnels A and B. Thus, it's clear that sound travels through liquids like water. Sound travels through liquids like water. Right. Okay. Here it's given, when shallow grounds are flooded, the sound of the vehicles traveling on the nearby roads can be heard louder than on other days. Right? If you all are living roadside, you can hear the sound of vehicles. If you have experienced this type of situation, You must have understood that when it's raining, especially if the area is little flooded, you can hear the sound of the vehicles more intensely. What is the reason, children? The reason for that is sound travels through liquids faster than through air. Now we learn that sound travels through air and sound travels through liquids. Now this is new information. The sound travels through liquids faster than through air. Sound travels through liquids faster than through air. Right, children? So this is very important information. This is the reason when the grounds are flooded, the sound of the vehicles traveling on the nearby roads can be heard louder than the other days. When there is no water also you can hear, but when there is water filled, you can hear the sounds better, which means sound travels faster and better through water or the liquids. Right, children? We'll move on to the next. Another activity we have to do. This is also to study about the propagation of sound. Okay? Finding out whether sound propagates through solids. Now we know sound propagates through liquids and also gases. Now we are going to learn about to check whether the sound propagates through solids. Now we are going to do a very easy activity. I am sure you all have done this activity when you were small. Okay? Right. So you need 2 yogurt cups to do this activity. 2 yogurt cups and a long thread. And a long thread. Right? 2 yogurt cups and a long thread. Right. Now when you see this structure, you all know that you have done this when you were small. Right? When you're in your primary grades, you all have done this activity. Right? You can still do this activity and check what happens. Okay? So connect the bottoms of the 2 yogurt cups to the thread as shown in the figure. We will label the diagram first. Yogurt cups and the thread. Yogurt cups and the thread. Right? Connect the bottoms of the 2 yogurt cups to the thread as shown in the figure. Then what do you have to do? Get the support of one of your friends. You need the help of another person. So at home you can ask your brother or sister or someone else at home. Okay? Get the support of one of your friends for this activity and keep one of the yogurt cups to your ear. Right? Tell your friend to go as far as possible. Now here, when you do this activity, now when you're in your lower grades, you must have made this as a small telephone, a toy telephone. Okay? So actually when someone speaks through this one from the other side, you can hear the sound very clearly. But there's one condition. To hear the sound very clearly, this thread should be well stretched. Right? So it should be well stretched. If these 2 are the cups, right. So if these are the cups, if this is how you keep them, when you are using it, this thread should be well stretched and straight. Okay, so if it is like this, you cannot hear well. Therefore, remember when you do this activity, the thread should be well stretched. Okay, get the support of one of your friends for this activity and keep one end of the yogurt cups to your ear. Right? Tell your friend to go as far as possible, keeping the thread well stretched. This is very important. Right. And speak into the other cup. Right? If you do this correctly, you can clearly hear the other person through the thread. Okay? I'll show you how to make this type of equipment now. Right, children? We are going to do this activity to show that the sound propagates or the sound travels through solid substances, okay? Now, I'm very sure you all must have done this activity when you were young, when you were in your primary school, okay? Right. So, it's very easy to make this instrument. What is this? Now, when you were small, you must have made this as a toy telephone, okay? Look, I have made this instrument with this toy telephone with two yogurt cups and a long thread. Now, actually, when you make this one, the thread should be even longer than this, about 8 to 10 meters. Okay, children? So, how to do this activity? How to show that sound travels through solids very well? In order to do this activity, we need two children. Right? You can ask your friend, or maybe at home you can ask your brother or sister to do this activity with you. So, what you have to do is one person, one child should take one cup and the other child should take the other cup. And one child should take onto the cup. Now, remember, in order to do this activity, when you are doing this thread should be well stretched. Now, here this is too long to show that. Therefore, I will take one thread from this side and show that how to stretch this one. Right? Right. Right. See, you all can see. Now, one child should take one cup and remember it should be well stretched like this. The thread should be well stretched and one child should speak into one cup. And the other child should keep the other cup like this to the ear. Right? The other person, when some other person speak into this cup, you have to check whether the other person has to check whether you can hear the sound clearly. Right? If the thread is like this, you will realize you can try it different ways. You can try it without stretching the cup. You will realize that you can't hear the sound from the other side well. Right, children? But when the thread is well stretched and when you listen through this thread using this cup, you will realize that you can hear the other one speaking into this cup very well, very clearly. Right? So that is why the thread should be way more longer than this, then only. Otherwise, what will happen? Before you hear it through the thread, you will hear it through air. Right? You have to go away from each other as much as you can and then do this activity. Right? When the other person says something slowly, even though you can't hear through air very clearly, you will realize that through the well-stretched thread, you can hear the sound very clearly. Right, children? So here the sound travels through the thread. Okay, children? Now thread is a solid object. Okay, it is a kind of a solid. Now what are solids, children? Solids have a definite shape and they occupy a definite volume. So this thread, when we consider, it occupies a definite volume and also it has a definite shape. Therefore, thread is a solid substance. Okay, a solid material. So in this case, even though when you use a very long thread, even though you cannot hear each other across air very clearly, you will realize that through the thread, you can hear the other person very clearly. Right, children? So by doing this activity, we can prove that sound travels better through solid substances. You can't hear each other across the air very clearly and at the same time, you can hear it well through the thread. That is because sound travels better through the thread, which means the solid substance. Right, children? So I showed you all how to make that instrument. So you can do this activity at home. Okay, so these sound experiments, you have to observe it at home because even though I could hear certain sounds, you cannot hear. That is why, therefore, most of these activities, the things that you can do at home, you try to do it at home. Okay. So what is the observations? Now observations, I just showed you all how to make the equipment, but when you do it at home or with your friend, you will realize that you can hear the sound of your friend very clearly. Right? Let's write. You can hear your friend clearly through the thread. Through the thread. You can hear your friend clearly through the thread, right? What is the conclusion? Why does this happen? Because sound travels through the thread, right? The sound travels through the thread. Now, thread is a solid medium. Therefore, the conclusion is sound travels through solids. Sound propagates through solids. Okay, children, let's write. The sound propagates through solids. The sound propagates through solids. Right, children? Okay, we have another activity to do here. Finding out whether sound propagates through solids. Another activity. Here we are going to prove that sound propagates through solids better than air. Okay? So what do we need? Now here the picture of a watch is given. Watch is also okay, watch with the tick sound. But better to use a small clock with a tick sound, right? And we need a long table, okay? A clock with tick sound, a long table. You can even use a stop clock here. That's also fine, right? Because it also gives the tick sound, okay? Right. So what is the method? Here it's very easy to do. You can do it by yourself. You don't need anyone else's support to do this activity, right? We will label this. This is the small clock, the long table. Long table. Right? Keep the clock at one end of the table as shown in the figure. Stand at the other end of the table and test whether you can hear the tick sound of the clock through the air. Right? You have to stand at one end of the table and you have to keep the clock at the other end. You have to check whether you can hear the tick sound of the clock through air. Right, children? Then what you can do is then place your ear on the table like this, right, as shown in the figure, and listen to the tick sound of the clock. You all can do this activity now. If you don't have a clock with a tick sound or anything else, you can simply ask someone else to tap on the table while you are listening. Right, children? We'll do this activity now. Right, children? Even this activity we are going to use to prove that sound travels through solids better than through air. Okay. Now here to do this activity, you all can use a ticking clock, or here I am going to use a stop clock. Right. Now when I switch this on, I can hear the ticking sound clearly. Check whether you can hear it clearly. Check whether you can hear it clearly, children. I'm sure you can hear it slightly, right? When I take it closer to my ear, I can hear it better. When I place it somewhere like here, I can still hear it, not very well. Right, children? Which means only when I take it closer to my ear, I can hear it very clearly than before. Okay? So what I'm going to do is I'm going to place this at one end of this table. Now remember, when you do this activity at home, you can use a long table. Longer the better. So you can use a long table and you can place the stop clock or the ticking clock at one end of the table, and you have to stand in the other side of the other end of the long table. Okay. So when I stand in this end, I can still hear it, what I'm going to do is I'm going to place my ear on this end of the table, right? Right, children. So when I place my ear, right, when I keep my ear on this end, I can hear the ticking sound way more better than before. Okay, children? So when you do this activity, now this is not something you can hear or you can observe. This is something I can observe. But remember, you all can do this activity at home very easily. Right? You have to experience this. Even though you heard the ticking sound of this stop clock, you could not observe what I observed here when I placed my ear on this end of the table. Right? I could hear the sound way more better than before. Okay, children? So here, in order to understand this, you all have to do this activity at home. You will experience this as I did. Okay? So after doing this activity, here what happens? When I hear the sound across air, what happens? I can still hear it. But using the table, through the table, I can hear the sound better. Right now, table is a solid object. Table is solid, which means when we compare air and solids, sound travels better through solids. This is the conclusion of this activity. Right, children? So you all observed. Even though you observed, you could not hear what I heard. Okay, that's why I said this type of activities you all have to try by yourselves. Okay, but I could hear the sound very well through the table than through the air. Okay, what we did was we placed this clock at one end of the table, right? And I tried to listen to the sound. I could hear a bit of the sound, the tick sound, but through the table, I could hear it way more better than that. Okay, let's write. The tick sound, can be heard through the table. More clearly than through air. The tick sound can be heard through the table more clearly than through air. Right? What is the conclusion? This happens because now we could hear through the air as well, but we could hear through the table clearly. Now table is solid. This happens because the sound propagates or travels through solids faster, better than through air. Right? Let's write conclusion. The sound propagates faster through solids than through a gaseous medium. Right, children? The sound propagates or travels faster through solids than through a gaseous medium. This is the conclusion. So now we know that the sound travels better in liquids and solids than that of gases after doing all these activities. Right? Right. So we have this assignment to do. Plan and do different experiments to show that sound travels through solid and liquid media. Right? So here we did some activities to observe that sound travels through these two different types of media. Well, let's think of another activity as well. So we can consider do you remember that I told you all about if you don't have a ticking clock, you can even tap on the table with a pencil or a pen. That's also fine. Okay, that's also one example. So the tabletop, you have to tap on the tabletop using a pencil or a pen. Okay, you have to check whether you can hear it through air. Obviously, you can hear it. But when you place your ear on the table, you can hear it much, much better. Now itself, you can do this activity and check this. Right? What else? So you can explain this one in words. When you do this activity, you have to explain, write it, draw a nice picture and explain. Right, children? Okay. So you can do this activity very easily even now itself. What about the liquids, children? What about the liquids? When you, now already we did one activity when we consider about that the structure we made using funnels and the tubes. We inserted one tube in water and we made sound in water and we could hear the sound we made in water through the other two funnels very easily. We can do a similar activity, children, right? Let's consider we can take a water basin, fill it with water. If you can find a small bell, what you can do is you can ring the small bell inside the water and you should try to place your ear somewhere very close to the surface of the water and try to listen to that. You will hear the bell very clearly. Right, children? So both these instances, you can show that sound travels through solid and liquid medium well. Okay, right. We have this extra knowledge part. Stethoscope is an instrument used by physicians to diagnose patients. You must have seen the doctors use this stethoscope. It functions in such a way that membrane of it vibrates accordingly to the sounds emitted by the organs like heart, lungs and pulses. Right? So the stethoscope is covered with. So when you consider the stethoscope, it has this type of part. It has a membrane-like part, right? It's covered with something like this. Right. So this part, one side of this is covered with a special type of membrane and that it vibrates according to the sounds emitted by heart, lungs and pulses. Okay? And here another instance. Sound pipes are used were used in the past in large buildings, ships and graphite mines to propagate sound to far away places. So in the past, there were no telephones, no mobile phones. Then what happened, children? There was no way to send messages. So in that case, in these type of instances, in these type of places, they used a special types of pipes called sound pipes. They used to speak over these sound pipes and send messages. Right, children? Okay. Right. Here, the sound of a train coming from far away can be heard clearly when the ear is kept on the rail line. So this is another method to prove that sound travels through solids faster than through air. But this is very risky. You should not try this at all. Okay, this is a very risky activity. Or you can, if you want to try, you can try it with the help of your mother or father, right? With the help of an adult, right? Without an adult, you should never ever try to do this type of risky activities, right? So sound of a train coming from far away can be heard clearly when the ear is kept on the rail line, because rail line is made up of metals, which means solids. Through the solids, we can hear the vibrations very well, right? The reason for this is that sound travels faster through solids than through the air. Right, children? Another example. We can hear the sound emitted by dolphins more intensely when we are underwater. So divers and people who do researchers, they can hear these type of sounds clearly when they are underwater. Why? What is the reason? Even earlier we learned that sound travels faster through liquids than through the air, right? But the same sound emitted by them above water is heard very lightly. right? The reason for this is that the sound travels faster through water than through air. Right, children? Okay. So look at this now. Now we all know that sound travels faster through liquids and solids than through the air or gases. What is the reason for this? We'll go through this. The speed of propagation of sound through solid, liquid and gaseous media is different from each other. Now we already know that, right? Sound propagates faster through solids than through liquids and gases, right? The speed of sound is least in gaseous medium, right? When you compare solids, liquids and gases, look at this table. Medium, air, it's a gas, right? It's a mixture of gases. Water is a liquid, steel is a solid, right? And speed of sound in meters per second, the unit given in meters per second. We will write here meters per second, meters per second, right? Look at this one. When it comes to air, the speed of sound is 330 meters per second, which means within a second, sound travels 330 meters through air. Through water, sound travels 1500 meters within 1 second. So much higher than this one, 330. Pay attention to steel. Here what happens? The speed of sound through steel is 4500 meters within a second. Right? Within a second, sound travels 4500 meters, which means 4.5 kilometers. Right? It's much, much higher than that of air. So it's very clear that when you consider air, water, steel, or solids, liquids, and gases, the speed of sound is highest in solids and lowest in gases. So we can write like this. Speed of sound highest in solids. So when you consider liquids, it's lower than solids but higher than gases. Right? Lowest in gases. Right, children? So what is the reason for this, children? For the reason you are going to learn in the upper grades too, but I will briefly explain the reason. Right, children? I will briefly explain the reason for this one. So when you consider solids, all solids, liquids and gases, they are made up of tiny particles. Right? When you consider solids, these particles are tightly packed with each other. They are very close to each other. When you consider liquids, these particles are loosely packed. They are not that close. There are spaces between. When you consider gases, what happens, children? There are large spaces among gaseous particles compared to liquids and solids. Okay, children? So here, when you consider the propagation of sound through solids, it's very easy because now we all know that there must be a medium for the sound to travel. Right? So in solid particles, in solids, what happens? The medium or these particles present, therefore sound can travel faster because these particles present very close to each other. One to the other, sound waves travel. When you consider liquids, because there's a certain gap more than the solids, it takes a longer time. But when you compare solids, liquids and gases, you all can see gases have more spaces in between the particles. Therefore, it takes a longer time for the sound to travel through gas. Because the space between there are a lot of spaces between the gaseous particles. Large spaces, that's why. Right, children? This is why sound travels fastest through solids and the lowest through gases. Okay? Right. Now pay attention to this. During lightning, thundering sounds and light are emitted at the same time. When it's raining, we all experience this lightning and thundering. Right? So here, during lightning, thundering sounds and light are emitted at the same time. But have you ever experienced that? Most of the time, we see the light first, but we hear the sound later. After a few seconds, we hear the sound. Right? But you're going to learn about this lightning and thundering later in the upper grades. Remember, they both occur at the same time, which means simultaneously. Right, children? They both occur at the same time. Right, children? Still, we see the light first. We hear the sound that occurs at the same time. We hear the sound a bit later. What is the reason for this? Right? The reason for this is that the speed of sound is slower than that of light. Light travels faster. You are going to learn later, light does not need any medium to travel. But when it comes to sound, sound needs a medium. Without a medium, sound does not travel. Light does not need a medium to travel. Because of this reason, remember, light travels faster. With or without a medium, light travels faster through substances. Right, children? Light travels faster than that of sound. Okay? This is very important. We see the light first, we hear the sound a bit later, even though they both occur simultaneously. Right? The reason for this is that the speed of sound is lower than that of light. Understood, children? Right. Okay. So we have another important part here. When a cannon is fired, this is also same incident, right? When a cannon is fired, the sound and the emission of smoke occur at the same time. When a cannon is fired, according to the firing, the light and the sound both, the smoke is given out and the sound is also produced. The large sound is also produced, right? But a far away observer hears the firing sound after few seconds of seeing the smoke. Someone who's close by will experience both the incidents, right? The smoke, they will see both the smoke and they will hear the sound at the same time, right? But when you consider a far away observer, that person hears the firing sound after few seconds of seeing the smoke. This is also the same reason, that is because when you consider light and sound, light travels faster than that of sound. Right, children? So I hope this part is clear now. So we have completed the entire lesson now. Right, children? So let's go see the summary to see what we have learned so far. Sound is generated due to vibrations. In this lesson, we learned the entire lesson under two main topics, the generation of sound and the propagation of sound, right? So we learned that sound is generated due to vibrations, okay? Sound can be produced by the vibration of membranes, strings or air. We learned that there are different types of musical instruments according to the way they vibrate, okay? A medium is necessary for the propagation of sound. Sound does not travel through a vacuum, which means there are no air particles or any other particles. Sound needs a medium to travel, either solid, liquid or a gas, right? The speed of sound is different in different media. Under this, we learn that the speed of sound is highest in solids and lowest in gases, right? The speed of sound is faster in solid media than in liquid or gaseous media. I hope you understood the entire lesson. So in the next chapter, we are going to do the exercise. So as usual, you all have to write the answers for the exercise questions before you watch that chapter. And then when I explain the answers, you can compare your answers with mine.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.